Hello everybody, and welcome to the boot camp. This is our fourth boot camp, right? And I'm here to present you a very important topic that we have to do today, which is linear regression analysis with R. I'll just tell you what is expected in this particular session. That first of all, we'll begin with linear regression with R. So, in this, we will be doing that. What is linear regression? And Today we'll be just completing the simple linear regression, and in our next session we'll move to the multiple linear regression. So initially we will do that what is linear regression, right? We will be doing the mathematical modeling with the linear regression, and then we will begin with that there are various methods by which we can estimate the value of b naught and beta 1, right, which are the parameters of the linear regression. So in this, we will be using two method, which is your least square estimation and other is your maximum likelihood estimation. So these two methods, so least square estimation, it is also called as your direct regression method. And then we have your uh, this is maximum likelihood estimation. So these two methods will be used for actually calculating B naught and beta 1, right? So we'll be using this and then we'll be taking an example, and based upon this, we'll be finding the value of beta naught and beta 1, right? So let's start with the session. So basically, what is a linear model, right? A linear model actually plays a very important part, right, in modern statistical method, right? So in this, we are going to use a model to approximate a large amount of metric data structure in their entire range of definition, or at least piecewise. So we use different terminology, and we have to understand that why we use the word regression, right? And in regression, our ultimate goal is to find a model. So we have to see that the model is whether good or bad, right? So model is dependable. That means, or the model is not dependable. So a statistical tool, they use regression analysis. So one of the problem that can destroy the statistical model is that if we do not have the proper knowledge of the regression model. So in this, we will be doing an example. So in which suppose we have to find out the marks of students, that depends upon several factors like number of hours per week of study, number of assignments submitted per month, and number of hours of play work per week, right? So these are the various factors. So when I say that, suppose the marks of students, right? So let me just use a pen, right? So we have to calculate the marks of students, right? So this marks of student, that is called as y. So that is called as your dependent variable, right? So this marks of student is called as a dependent variable. And when we say the number of hours per week or the number of assignments submitted per month or number of hours of play, this is called as x1, x2, and x3. So this is what these are called as your independent variable. So when I say that the number of hours per week of study, that is x1, number of assignments submitted per month, that is x2, and number of hours of play per week, that is x3, right? So we have to see that y. So we have to see y is equal to f of x1, x2, and x3. So what does that mean? That y, the value of y is dependent because it's a dependent variable and it is dependent upon x1, x2, and x3, where x1 is the number of hours per week of study, x2 is the number of assignments submitted per month, and x3 is the number of hours of play per week, right? So if we want to find out the relationship between the marks of students and the number of hours per week of study, the number of assignments submitted per month, and the number of hours of play per week in terms of a mathematical equation. So we have to use a mathematical equation in this. So this examples can be shown with the help of a data. So y is, what is, we already have got the value of y, right? We have got the value of x1, x2, and x3. So what is interesting over here is that we have the data, right? And based on that, we have to calculate the value of B naught and B1. So what is B naught and beta 1? That I'll just tell you in the future slides, right? So you can say, just read the example. Observation of 20 students are collected, right? And y is equal to the marks of students. X1 is the number of hours per week of study. X2 is the number of assignments submitted per month. X3 is the number of hours of play per week, right? So we have X1, X2, X3, which are the independent variable, and Y is the marks of the students, which is a dependent variable. So we have to find F. So what is F? F is the function. The relationship is Y is equal to F X1, X2, X3. So what is F? F is actually the function, right? So we have to find the function. So what is F1? F is actually the function that we need to find out. So we can see over here. So form F is unknown. F can be linear as well as non-linear. So F can be linear as well as non-linear. Relationship is more known when F is known. So if we have to find out the relationship will be known when the F will be known, right? Okay. So if we want to know the relationship, so we know the relationship is known when the value of F is known. Then only we can know the relationship. Otherwise, it is very difficult to know the relationship, right? So X1 we know it is the number of hours per study. X2 is the number of hours. Okay. X1 is the number of hours per study, which we already know. X2 is the number of hours uh, of assignment submitted. X3 is this, and this is the relationship, right? So F can be linear and non-linear. So that means we do not know that what is the value of F, X. It can be linear or it can be non-linear. So it can be linear as well as it can be non-linear. Okay. So y is equal to f x1, x2, x3. Form f is unknown. F is the linear as well as non-linear. Relationship is known only when f is known. So here we have two types of variable, input variable or the independent variable, output variable or the dependent variable. So what is our objective? Our objective is to determine a relationship between dependent and independent variable, which describe the phenomenon process is the best possible way. So we have to find out that what is the relationship between the dependent variable and the independent variable, right? So we can say that we already know that what is the input variable. We already know what is the output variable. We already have an idea about the input variable and the output variable. So input variable, we know that is x1, x2, and x3. Output variable is y. So we have to find out that what is y is equal to f x1, x2, and x3. That is what we need to find out. Now we come to model. What is a model, right? So model is actually a representation of a relationship. So whenever we say a relationship, that can be between a father and a son, or mother and a son, or a teacher or a student. So that is a relationship, right? So a model is actually a relationship, right? Statistical role. So when basically a statistician is working on the data, or when is working on any of the model, these are the rules that he follow. That means he cannot change or alter a process. That is not possible for a statistician. Like whatever is happening will continue to happen. A statistician cannot change or alter the process. A statistician work only on a basis of a sample. Now, what is a sample? A sample is a small fraction of the population, right? So sample is expected to have all the feature of the population. So suppose if we have a medicine and we take some sample of that medicine, now we find that people in America take eight basically that control the temperature. So we know that in America, the temperature can be controlled by 8 hours, whereas in case of European, they normally the temperature is controlled by 4 hours. So that is not possible, right? Then it is not the correct way, you know, to actually judge a sample, because when we say sample, it is actually a representation of the entire population. So then we have to say the sample represent the entire population. We cannot say that it is just having uh, one, or it is different for different location. Otherwise, if it is like, if it is not affected by geographic, then we can say that if it is affected in some of the cases, there may be geographical, boundaries which basically affect the outcome. So that is a different. Otherwise, like some medicine that is as good for the European, that will be good for the American as well. So in that, that means a sample is expected to have all the feature of the population. So next we come to data generate the process. So when we normally talk about a problem, it's basically goes the other way around, right? So whenever we talk about a particular problem, we say, uh, okay, so I think just give me 1 second. Okay, so now let me get back to the slide. So we were discussing about the basic. So as you can say that in the basic, the process generate the data, which is correct. So process generate data which is correct, or data generate process that is wrong. So when we talk about a process, we already know that first of all, we have to use a mathematical relationship and then we have to generate the data. But let's say if data is there and we use a mathematical relationship, which basically determines the relationship between the regression analysis, then we generate the process. So in this, we'll be doing a different. That means we will be using our data in order to generate the process, right? So here we'll be using the data to generate the process. So let's get back to this. So we already talked about the statistician role. So now we come to the linear model. So when we talk about the linear model, we basically talk about the input variable. So the input variable are fixed. That means there can be y variation is coming. So variable is affecting the output variable, right? So input variable is fixed, whereas the output variable is a random variable, right? So input variable are fixed, so they are also called as the independent variable or the explanatory variable that is basically designated by x1, x2, and xk. And the output variable, which is y, which is a dependent variable that is basically represented by y, which is also called as a study variable or a dependent variable and a random variable. So we have to find the relationship by y is equal to f x1, x2, xk, beta 1, beta 2, beta k plus e. So e over here is epsilon. So when we consider a relationship, suppose if we have to consider, let's say, y is equal to mx plus c. So what is m? M is considered as the slope and c is considered as the intercept, right? So this equation becomes like, suppose if x is given as x is given as 1 and y is given as 2, then we know y is equal to m plus m, that means 2 is equal to m plus c, right? So this is one equation. And suppose if m is equal to 1 and if c is equal to 2, then we know y is equal to x plus 2, right? So when x is added twice, we get the value of y, right? So in the linear model, we have f is basically some defined function, and beta 1, beta 2, and beta k are the parameters, right? Which basically characterize the role and contribution of x1, x2, and xk, right? So beta 1 basically characterize the role of x1, beta 2 characterize the role of x2, beta k characterize the role of xk. And what is this E? This E is also called as a very important part of linear model, which is it is called as the random model or epsilon, right? Basically, it tells you the stochastic relationship between x and y, right? So there is always a random error. Whenever we are talking the mathematical form, E can be equal to 0. But whereas when we are talking in the form of statistician form, E is never equal to 0. So that is why epsilon represent a error. So therefore, Y is called as the random error. Now, Y is called as the random, uh, uh, like this, a random variable because of the epsilon. Epsilon is a random error. The presence of random error makes y a random variable, right? So epsilon is equal to 0. This relationship is called as a mathematical model. And when epsilon is not equal to 0, then this relationship is called as a statistician model or a statistical model. The term model is broadly used to represent any phenomena in the mathematical framework, linear and non-linear. So why a model is called linear and why the model is called non-linear. So when we basically define the relationship between the model, which is linear, that is why a model is called linear. So sorry, where is the example gone? Okay, so whenever we find the relationship between a model which is linear, therefore the model is called as the linear model. Suppose if we find the partial derivative of y, with respect to each of the parameter like beta 1, beta 2, beta k, and that is independent of the parameter, then it is called as a linear model. And suppose if we find the relationship of E of y, like a partial derivative of y with respect to beta 1, beta 2, and beta k, and it is not independent of the parameter. So that is why it is called as the non-linear, right? So this is the partial derivative of y with respect to each parameter, beta 1, beta 2, beta k are independent of the parameter, then the model is called as the linear model. And if we use a partial derivative of y with respect to any of beta 1, beta 2, beta k that is not independent of the parameter, then the model is called as non-linear. So we have to know that the linearity or non-linearity of the model is not described by the linearity or non-linearity of the explanatory variable. So we should know the explanatory variable or x1, x2, and x3 do not actually identify the linearity or the non-linearity of the model, right? So x1, x2, and x3 do not play any part in finding out whether the model is linear or it is non-linear, right? So suppose if we take this example and we see over there that if we basically find out in this example that what is dey upon d of beta I. So it could be like a beta 1 or beta 2 or a beta 3. So if we use this, what we will get over here is that we get over here that this is this will be like beta 1, this is beta 1 x1. So this will be the same, right? And this will be equal to beta 2 under root x2, right? So this will be x1 square, right? This will be your under root x2, right? And this will be your log x3, right? So beta 1 is this. Now dE upon d of beta 2 is this, and dE upon d of beta 3 is this. So we know that the value is independent of beta 1, beta 2, and beta 3. So we can say that this is the linear model, right? Whereas if we do this equation, it is beta 1 x1. So if we will do dE upon dEy upon d beta 1. So this value is going to be 2 beta 1 x1. And if we do dEy upon d of beta 2, this will be x2. And if we will do d of e of y upon d of beta 3, this will be log x, right? So this is independent. This is independent, but this is dependent upon p, right? So this is dependent upon beta 1. So this model is a non-linear model. So I hope that it's clear that why it is a nonlinear model, because the value of dEy upon d beta 1 will be dependent upon beta 1. So therefore, it is a nonlinear model. So we can say model can be divided into two types. It could be a linear model or it could be a nonlinear model. So linear model contains the linear regression model, which we are going to discuss in detail. And the nonlinear model consists of nonlinear regression model. So linear regression models are linear in parameters, they are linear in variables, and the nonlinear in parameters and linear in regression. So now we know what is regression. So when we say regression, that means we have to move backward. So when we use the word regression, that means we have to move in backward direction. That is what the regression means. So here what we are having is we already have a data, and based upon that data, we have to calculate the process. So that is why it is called as the regress, or it is called as the regression. So we take an example of a linear regression model. So again, we have got Y, which is the marks of students, and they are dependent upon the number of hours per week of study, which is X1, number of assignments submitted per month, which is X2, and number of hours of play per week, which is X3. So we have to find the relationship between Y1, which is Y, and X1, X2, X3. So basically, what do we write it is that we write y. So how do we write it? So yeah, I'll just use a pen. So we write y is equal to x1 beta 1 plus x2 beta 2 plus x3 beta 3 plus epsilon. So this is the equation of writing the linear regression. So here beta 1, beta 2, beta 3 are true values in nature, but they are unknown to the experimenter. So experimenter doesn't know what is the value of beta 1, beta 2 and beta 3. So some values of y is recorded by providing the different values. So we already have a value of x1, x2 and x3 and some value of y is recorded. So there actually exists a relationship between y and x1, x2 and x3 which give rise to a systematically behaved data on y, x1, x2 and x3. So such relationship is unknown to the experimenter. So in order to determine the model, we are going to move in the backward direction. That means we already have the collected data and we have to determine the unknown parameters. So what are the parameters over here? We know the equation y is equal to b naught plus beta 1 x. So b naught is your intercept and beta 1 um, is your slope. So what we have to find out, we already have y, we already have x, we have to find beta naught and beta 1. So the unknown parameters are beta naught and beta 1 that we need to find in terms of our regression analysis. The theory and fundamental of the linear model lay the foundation for developing the tools for linear analysis that are based on valid statistical theory and concept. So here are the steps that you need to follow in order to do a regression analysis. So the first step says that, first of all, you have to identify the steps, right? First of all, you have to identify the steps uh, of the statement of the problem under consideration. So first of all, you should know that what is your problem? What is the problem that you want to work upon? The problem here is that we have to identify the marks of the student based upon some independent variable. Then we have to choose the relevant variables because we have a huge data set. In that, we have to identify that what are the relevant variables that we have to select based upon this particular problem. So there would be a variable y, which is your dependent variable, and there would be a variable x1, x2, x3, x4, whatever variable we have to choose, right? So then we have, but like in linear regression, we'll be just taking a single variable over here, right? Then we have to choose the relevant variables, right? So relevant variable is very important. Variable here basically consists of two things, the independent variable over here and the dependent variable. So dependent variable is one, independent variable is also one over here because here we are only talking about the linear regression. When we will come to the multiple linear regression, there we can have more than one independent variable. So there we can have 3, 5, 7, like independent variables, right? But dependent variable is always 1. So this is your y, and suppose this is x1, let's say, for this linear regression. Then we have to collect the data on the relevant variable. So data collection is very important because see, this is the data that has been collected. You see over here, like suppose if we are going to take y and x1, so we have collected the data. So the third step is that we have to collect the data. So we should know what is the value of y if the value of x1 is given. Then we have to do a specification of the model, right? Then we have to specify the model. Let's say v is equal to beta naught plus beta 1x. So we will do the specification of the model. Now, this fifth step is very important because this is what we are going to do after we finish with the basic. Choice of method. So there are actually two methods that we are going to do in this particular session, which I already told you. So the first method is called as is your least square estimation. So two estimation that we will do. First is your least square estimation, which is also called as your method of least square. And next method is your method of maximum likelihood. So these two different methods which we will be doing, and these are two different methods. All these two methods are used to find the value of beta naught and beta 1, right? So these are the two methods we'll be doing. Then fitting of model is done. Model validation and criticism is done. And then we have to use the chosen model for the solution of the post problem and forecasting, right? So as you can say that these are the 8 important steps that you have to consider in order to do the regression analysis. So these steps are very important, and you have to consider these steps in order to do your regression analysis. So I hope you understood very well that what are the 8 important steps that we need to consider. So the next we come to simple linear regression model. So now on, after telling you the basic of what is regression model and what is the independent variable, what is the dependent variable, what are the steps of the regression analysis, we come to our first model, which is your linear regression model, right? We also call it as a simple linear regression model, right? So we consider the modeling between the dependent and one independent variable. When there is only one independent variable in the linear regression model, the model is generally termed as, so what is a simple linear regression? Simple linear regression means that this model only uses one independent variable, which I already told you that one independent variable is there in a simple linear regression, and there is one dependent variable, right? So in case of a linear regression, there is one independent variable and there is one dependent variable, right? So one independent and there is one dependent. So this is like x1 and this is your y. So we use y is equal to b naught plus beta 1 x, right? Or beta 1 x1, right? So when there are more than one independent variable in the model, then that model, that linear model is called as your multiple linear regression, right? So if there are more than more than one independent variable, we call it as a multiple linear regression, right? And there's one more model over here which we're talking about. That is your like multivariant linear model. So suppose if there are more than one multiple linear regression model that are to be considered together, then it is called as your multivariate linear regression. But here we are just going to consider your simple linear regression and multiple linear regression. So here in this, we consider the marks of students depend upon one variable, which is the number of hours per week of study, right? So this marks of students depend upon only one variable, which is number of hours per week of study. So we have to find the relationship between the marks of the students and the number of hour per week of study in terms of the mathematical equation. So we have to know that we have to find y is equal to f into b naught plus beta 1x, right? So we have to find that what is the relationship between the marks of the students and the number of hours per week of study in terms of mathematical equation. So in this, we have an observation of 20 students and where y is the marks of the students and x is the number of hours per week of study. So here we have a simple linear regression model. So in this simple linear regression model, we have the equation y is equal to beta naught plus beta 1x plus epsilon. So here y is the dependent variable and x beta 1x. Here y is called as your dependent variable, x is called as your independent variable, beta naught is the parameter. Beta naught and beta 1 are your parameters. They are also called as your regression coefficient. And beta naught over here is your intercept term. Beta 1 is called as the slope parameter. So it's very important for you to understand that what are the different parameters of this model. Beta naught is your intercept term. Beta 1 is your slope parameter. And here epsilon is the unobservable error component. So it's very important for you to identify what each of the term here represent. This y is called as your dependent variable, right? So you should know that it is a dependent or your study variable. This x over here is the independent variable, or it is also called as your explanatory variable. Beta naught is called as your intercept. Like when we make a graph between y and x, so this line that cut y-axis, this is called as your beta naught, right? And whenever we are going to find out that this is the, like this is the difference, so this is called as beta 1, right? So that is called as your slope. So slope can be y2 minus y1 upon x2 minus x1, right? So that is the slope of your uh, equation, right? So it's the slope parameter. This epsilon, this is also called as your error component. So this is a random error, or it is also called as the random error component, right? So I hope you all understood that what are the different types of uh, the methods we are having. So terms we are having for the different parameters. So next we come to the epsilon, right? So what is epsilon? Epsilon is basically identify as a random error, right? So it accounts for the failure of data to lie on a straight line and represent the difference between the true and the observed realization of y. So whenever we use the word epsilon, it is also account for the failure of a data. So it basically identify that it is a failure of a data to lie on a straight line, and it represent the difference between the true and the observed value. And it is also termed as a disturbance or the random error or the error term. So this is the epsilon. It is also called as your error term, right? So I hope this is understood that what is epsilon means over here, right? So there are several reasons for such difference. Example, the effect of all the deleted variables in the model. Variables may be quantitative, qualitative, and inherent randomness in the observation. So the reason that we have epsilon, there are several reasons for having epsilon. It could be the reason of deleted variables in the model, or it could be variables may be qualitative or inherent randomness in the observation. So here, when we say epsilon, epsilon is independent. So the value of epsilon is independent and identically distributed random variable with mean is equal to 0. So when we say expected value of epsilon, that is taken as 0, and variable variation of epsilon is equal to sigma square, right? So what is the variation of epsilon? The variation of epsilon is equal to sigma square. So later we will sorry. Later, we will additionally assume that epsilon is normally distributed. The assumption is more importantly needed for confidence interval estimation and test of hypothesis. So when we talk about a simple linear regression model, the independent variable is viewed as a controlled by the experimenter. So it is considered as a non-stochastic, whereas y is viewed as a random variable. So when we say EY is equal to beta naught plus beta 1x, right? And we say variable of y is equal to sigma square, right? So variable of y is equal to sigma square. So in a simple linear regression model, we have to know what is the value of parameters and value of observation. And then we have to identify the observed and the collected values which are used to identify the unknown parameters. So again, we will come back to our example in which we have taken 20 observation and y is the dependent variable which represent the marks of the students and x is the number of hour per week of study. So here we have to estimate the parameter based on simple linear regression. So as I told you, we have various methods of estimation that can be used to determine the estimates of parameter. Here we'll be using two methods. The two method we are using is the least square estimation method, and the next method is your maximum likelihood method, right? So these two methods that we will be using over here, right? So this is also called as your direct regression method, right? So this method is called as your direct regression method. We will be just taking this in short while. So the first method is your least square estimation. So we will be just talking about this method, which is called as your least square estimation. So what does it basically represent? It represents that suppose if we have n paired of observation, xi, yi, I is equal to 1 to n, which is available. So in this, the equation of y becomes b naught plus beta 1 x plus epsilon, right? So here the value of yi is equal to beta naught plus beta 1 x plus epsilon. So this value epsilon is the random error that basically represent the difference between the observed value and the fitted value. So in this, we can see that this method of least square estimate the parameters beta naught and beta 1 by minimizing the sum of squares of difference between the observation and the line in the scattered diagram. So this particular line, this is your beta naught, which represent the intercept, right? And these are the values which are on this line. This line is called as the best fit line. And in this, there are the values. These values basically represent the fitted values. The values on this line represent the fitted values, and these are the observed value. These values are called as the observed value. So we have to make sure that whatever is a difference between the observed value and the fitted value, that is actually minimum, right? That is why it is called as the least square estimation or the direct regression method. So this method of least square estimate basically assumes that we basically estimate beta naught and beta 1 by minimizing the sum of square of difference, right? So always whenever we are going to take the difference between the observed value and the fitted value, it we are taking the sum of square of difference. And this difference is minimum. It should be minimizing, right? Based upon this scatter diagram. So this is the scatter diagram where basically we see the points and then we create a best fit line. In the best fit line, we basically see what is the difference between the fitted value and the observed value. So this difference should be minimum in order to find out the least square estimation. So least square estimation is a vertical difference between the observation and the line in the scatter diagram is considered and the sum of the square is minimized to obtain the estimate of beta naught and beta 1. So this method is also known as a direct regression method. Least square is required about a form of probability distribution of epsilon in deriving a least square estimate. For deriving the statistical inference about mean variance and other properties of least square estimate, we assume that expected value of epsilon is equal to 0 and the variation of epsilon is equal to sigma square, whereas the covariance of epsilon I and epsilon j is equal to 0. So we assume that epsilon is normally distributed and is utilized while constructing the test of hypothesis and the confidence interval of the parameter. So this is a direct regression method. So as you can see that we write yi is equal to beta naught plus beta 1 xi plus epsilon. So suppose if we have to take the value of this epsilon, that will be equal to summation of yi minus beta naught minus beta 1 x1, and this is whole square, right? So we have to make sure that this is the minimum, right? So we have to use the principle of least square to obtain the ordinary least square estimate of beta naught and beta 1. So here we are going to take the partial derivative of beta naught and beta 1 in order to find out these values. So we can see over this in detail that how to find out the partial derivative of S B naught B1 with respect to B naught and with respect to VB1. So this is actually written over here directly, but we can do it with the help of the chain rule. So let us just take this in detail. So we are going to first of all take the value of E. Let us do a slideshow from the current slide. So in this, we will first of all take the value of E, which is equal to summation of, okay, we take the value of E, which is equal to summation of yi minus b naught minus beta 1 x1 whole square, right? So we need to find what is dE upon dB0, and we need to find the partial derivative of dE upon dB1. So this is what we have to do. That means we have to find the partial derivative of dE upon dB0 and partial derivative of dE upon dE1. So first of all, we are going to differentiate it with respect to B naught. So in this, we are get E is equal to summation of yi minus beta naught minus B1 xi whole square. So here we are going to find out the derivative. So let's start from there. E is equal to summation of yi minus beta naught minus beta 1 xi whole square. So here we know that if we use a derivative of u square, so this is going to be d 2u du by db naught. So here we know that u is equal to summation of yi minus beta naught minus beta 1 xi. So if we have to find du upon db0, this will be coming out to be, because y is actually uh, constant, so this will be 0. And du upon db0, this will be minus 1 over here, right? Suppose we will have like this value will be minus 1, right? So we can say like we will be having db upon db0 upon minus d minus b0. And this will be again db uh, d upon db0 minus b1 xi. So this will be again 0. So this will be 0 plus minus 1 plus 0, because this is a constant with respect to b0. So that's why this will be 0 and this will be 0. So hence we can say du upon db0 will be equal to minus 1. So this is what we have got by finding out du upon db0. So next we have to find out that uh, here du, just a moment. Here du upon db0 is equal to minus 1. We already have found out. So next we will find that what is the next value with respect to dE upon dB0, right? So this we already know that here it will be summation of 2 upon yi minus beta naught minus beta 1 xi into minus 1, right? Because it was square, so 2 came over here, and rest it will be same yi minus beta naught minus beta b1 xi into minus 1. So we will just take minus 1 over here. So, and we will take minus 2 summation of yi minus b0 minus b1 xi, right? So then we will just have the value x summation of yi minus beta naught minus beta 1 xi is equal to 0. So when we will expand the summation, here we will get summation of yi is equal to summation of beta 0 plus beta 1 summation of xi, right? So this will be summation of yi will become nb0 plus beta 1 summation of xi. So this will be your first equation. This will be considered your equation 1 when you will find dE with respect to dB0. Now we come to the next part. which is your partial derivative with respect to your. So next what we are going to do is we are going to find the partial derivative with respect to B1. So we are going to do a partial derivative with B1. So then it will become E is equal to epsilon yi minus B naught minus beta 1 xi whole square. This is your equation. So U will be epsilon of yi minus beta naught minus beta 1 xi, right? So this will be just your value of this. So next we will do du upon, we just move this, du is this, du upon db1. So this will be 0, this will be 0, and this value will be minus xi. So that is the value of du upon db1. So next we are going to apply the chain rule and find de upon db1. This will be equal to summation of 2 yi minus beta naught minus b1 xi into minus xi, which we have found by du by db1. So this will be minus 2 summation of xi yi minus beta naught minus beta 1 xi, right? So this will again become summation of xi yi minus beta naught minus beta 1 xi is equal to 0. So when we will expand this, suppose when we will expand this, we will get summation of xi yi minus beta naught summation of xi minus beta 1 summation of xi whole square is equal to 0. So this will become summation of xi yi is equal to beta naught summation of xi plus beta 1 summation of xi whole square, right? So this is how we have to solve the value. Now we have the equation 1 and equation 2. So what is this? This is your equation 2. So based on this, we will find the value of B naught and B1. So here we have equation 1 and equation 2. So your equation 1 was that summation of yi is equal to nb naught plus b1 summation of xi. And here we have your equation 2, which was summation of xi and yi is equal to b naught summation of xi plus b1 summation of xi whole square. So when we put the value in this, we get b naught is equal to y bar minus b1 x bar. So this is the value for b naught. And when we get the value of b1 is equal to n summation of xi yi minus summation of xi summation of yi upon n summation of x whole square minus summation of xi whole square. So these are the value of b1 and b naught that we get. So as you can see in this is what the value we are getting. That means this is a partial derivative of x b naught b1 with respect to b. So this is a partial derivative. Y minus is given because whenever we are going to take a derivation of du with respect to db0, this becomes minus 1. So therefore we get minus 2 and this is the value we get. Similarly, when we take a partial derivative of s b naught b1 with respect to beta 1, therefore we take this value as u first, and whenever we find a value of du upon d beta 1, we get as minus xi. So that is why we get a value of minus 2 summation of yi minus beta naught minus beta 1 xi. So after this, we have a solution for beta naught and beta 1. So ds of beta naught beta 1 upon d of beta naught is equal to 0. So we have this value. And similarly, the partial derivative of b naught and b1 with respect to beta 1 is also equal to 0. So this solution of two equations are called as a direct regression estimator, and that is also called as your ordinary least square estimator of beta naught and beta 1. So in this, we find these are the value of beta naught and beta 1 according to the ordinary least square estimator method. So what is the value of beta naught? The value of beta naught that we get was y naught minus b1 x bar. So as you can see in this method, this is the value. We had these two equations which we have calculated, and based on this, we get the value of beta naught, which is y bar, right, minus b1 x bar, right? So this we have now what we do, how do we get this value? Because we know that whenever we are going to write this equation, sigma of yi is equal to nb naught plus beta b1 summation of si. So suppose if we take this equation over here, we get summation of yi minus b1 summation of xi is equal to n b naught, right? So here we are going to take n over here, like summation of yi upon n minus b1 summation of xi upon n is equal to b naught. So what is summation of yi upon n? It is called as y bar, right? As you can say, the mean, like as you can see over there, y bar as the mean. So y bar is equal to summation of y upon n. And x bar is also the mean of x, which is summation of x upon n. So we get b naught over here, which is y bar minus b1 x bar is equal to b naught. So this is the same method. We got a value b naught, which is equal to y bar minus b1 x bar. Similarly, the value of b1. So value of b1 become sxy upon xxx, right? So this is similar. This is xxy and this is xxx. So you can see over there that your b naught is equal to y bar minus b1 x bar, and b1 is coming out to be xxy upon xxx. So what is xxy? X xy is equal to summation of xi minus x bar and yi minus y bar, right? And xxx is equal to summation of xi minus x bar whole square. So this is the value of b1. So with the help of ordinary least square method, we have calculated what is the value of b naught and b1. So now this is a direct regression method. We have to find the partial derivative of b naught b1 with respect to b naught, and of this with respect to beta 1. So you can see over there that first of all we have to find the partial derivative over here, and we got this. We already have done this before by using the partial derivative with respect to db naught. And in this, we take minus 2 and we summation of yi minus b naught, summation of 1 minus beta 1, summation of xi. So here, summation of yi can be written as ny bar, because we know y bar is equal to summation of yi upon n. So summation of yi become ny bar. Similarly, summation of 1 can be written as n, and summation of xi can be written as nx bar, right? Similarly, we have to find out with respect to beta 1. So in beta 1, we have this value summation of xi yi. This is xi is here, and minus n beta naught minus beta 1 summation of x square. So from this, we get the same value of beta 1, which is sxy upon xxx. And beta naught is equal to y bar minus beta 1 x bar. So same value we are getting for b0, for like beta naught and for beta 1. So next we have the direct regression method. So the same values are coming. The ordinary least square estimate of beta naught and beta 1 are denoted by b0 and b1. So b0 is equal to y bar minus b1 x bar, and b1 is equal to xxy upon xxx, where xxy is equal to summation of xi minus x bar, yi minus y bar, and xxx is summation of xi minus x bar whole square, where x bar is equal to 1 by n summation of xi, and y bar is equal to 1 by n summation of yi. So again, we have used a second order partial derivative by using a Hessian matrix. And in this, we have basically find the second order derivative. So this we have got n over here. This is nx bar, and summation of x square. Next, we are going to find out the determinant. So this will be the value for the determinant. So this y is equal to b naught plus beta 1 x plus epsilon. Beta naught represent b0 and beta 1 represent b1. So y is equal to b naught plus beta 1 x b1 x. So here we have find the model. We have basically have to know the value of parameter, which is b naught and beta 1. So we have to know what is the equation of straight line, which is y is equal to mx plus c, where m represent the slope and c represent the intercept. So Ey is equal to b naught plus beta 1 x. So we have to find that what is the value of derivative y with respect to x. And if x is given to 0, if x is given a value 0, then we can say that b naught is equal to Ey. So average value of y when x is equal to 0. So similarly over here, we know that Ey is equal to beta naught plus beta 1 x. Beta 1 is a slope parameter and beta 1 is equal to dEy upon dx. The rate of change in the average value of y when there is a unit change in x. So suppose if we have a value b1 is equal to 2. So if b1 is equal to 2, that means that for every value of which is twice of x, right, the value of marks will be twice, right? Suppose if the value of x is increased by 2, the marks will be also increased by 2. And in this, if we take as beta 1 as 0, then we have a value or like x is equal to 0, then we can say that even if there is no change in the value of x, marks will always be 30 in that case. So the best fitted line here means y is equal to b naught plus beta 1 x and y hat, which is your fitted line, that is equal to b naught plus beta 1 xi. So this is the difference between the observed value, which is yi, and yi hat, which is the fitted value. So now we come to the residual. The residual is a difference between the observed value and the fitted value. So this is the fitted value and this is the observed value. So whenever we have to find a difference between the observed value and the fitted value, this is called as the residual. So this is the difference over here is the E and it is also called as the residual. So now we are going to use the model fitting using R. So we use LM over here, which is the linear model, and this is used in order to find out that what is the value of B naught and beta 1, which are called as the coefficient. And we can also find the residual with the help of the residual function and fitted dot values with the help of fitted dot value uh, command. So next we come to this same method in which we will take a vector y and a vector x, and then we will find that what is the linear model between y and x. So let's do this in R. So now we'll open R and do the same in R. So the first command says that we have to make a y parameter, right? So this y is your dependent variable. So we will first of all take the value of y and run this command. So now the value of y is created. In order to know it, we will again run the value of y and this value can be seen over here. So this y value basically represent here the marks of the student. Similarly, we'll be taking the value of x. Now this value of x represent the number of hours the student studies per week, and this is also the independent variable. So we will take the value of x, we will run this command, and again we just want to find out that what is the value of x. So this is the value of X. So after this, we are going to find out that what is the model, right? We have to represent the model. So we are going to first of all call the model. So first of all, we will plot the model X and Y. So in this, we are first of all going to plot the model. So this will how the model will look like. So these are all the scattered value, and we will make a line. This is what a fitted line looks like. So this is a fitted line. These are all the data which is scattered above and below the fitted line. And whenever we find that the observed value and the fitted value, that is called as the residual. Now, in order to find out that what is the value of LM and X, we are simply going to write LM linear model Y Tiddle sign NX. So when we will run this, we will get a formula where LM is the linear model and coefficient, it will represent intercept. So intercept here means beta naught, and this value X is the value of beta 1. That means beta naught is 75.779 and beta 1 is 3.407. In case if we have to find out that what is the coefficient, we can also do it with the help of the coefficient command over here. So we are just going to write the coefficient and we will just run this command. So we can see over here the same output we are getting in the coefficient. The only difference is that we are writing a coefficient over here, a command, but here we just wrote lm y tiddle s. So in case if we have to find out that what is the fitted value. So for this, we have to use the fitted value command. So simply if you're going to write fitted dot value and you have to give in this the model, and when you run this command, you get the fitted value. Next, when we have to find the residual, that is between the value of y and y hat. So we are going to give the command residual lm y y tiddle x. So we will get the value of residual. So this is, we give the command and these are the residuals for the value of residuals that we get for every point. Because we should know for every point, we have to find that what is the difference between the observed value and fitted value. So this is the residuals that we are getting for every command. So I hope this is clear. You can all see this command over here. And I will also just tell you about the graph because this graph over here represent okay, I'll share the slide with you all. So this was all about the R over here, the R command that you have to know in order to understand the linear regression. So in this, we will be talking about model fitting using R. So we have to write a command y is equal to b naught plus beta 1 xi plus epsilon. So this basically, when you write plot xy, this is the first thing that you get. So here you get all the scattered point which is written, which is drawn between y and x. Y over here is the dependent variable and x is the independent variable. Here you have got four fitted lines. So here you want to see that which is the best fitted line. So as you can see over here that in this particular line, the lot of points are above this point, lot of data is above this line, and lot of data is below this line. So this is definitely not the best fitted line. So we won't call it as a best fitted line, right? So this is not considered. Similarly, over here, a lot of data is on the right of the fitted line and a lot of data is on the left of the fitted line. So therefore, it is also not the best fitted line. Similarly, in this, the same case is there where the data is scattered everywhere on the graph and it is very far away from the fitted line. Therefore, this is also not the best fitted line. But here in the last case, we can say that a lot of data lies just near to the fitted line. So whenever we have to find a difference between the observed value and the fitted value, which will be minimum, right? which is the aim of the ordinary least square method. The difference between the square of the difference between the fitted line and the observant point should be minimum. So therefore, this is considered as the best fitted graph for your model. Similarly, we have used these commands already. LM, Y, tilde X. So they basically represent the coefficient 75.779 and X 3.407. So model fitting using R. So this interpretation you should know that this coefficient B naught is the same formula that we use Y bar minus B1X. This represent B naught. And for X 6y upon xsx represent b1. So that's a value of b1. So with this particular command, we are able to find our coefficient b naught and beta 1. So y is equal to 75.779. So now we can represent this in the form of the equation because we have found b naught and beta 1 and x and y are given to you. So x is given to you. So in future, if you want to know what is the value of y, if the value of x is given to you, then you can use the equation y is equal to b naught plus beta 1 x. So in case if x is given and y is not given, if with the value of beta naught, which is 75.779 and beta 1 which is 3.407 and x1 is given to you, suppose it is let's say 3, which is not given before. So you can find that what is the value of y, right, with the help of this. So here you can say that x is the number of hours per week of study, and this is your uh, beta 1, which is the slope, and this is your intercept, which is 75.779, and marks is the dependent variable, right? So we have found the value of the coefficient beta naught and beta 1, which is our aim, right? And the interpretation basically says over here that when a student studies 1 hour more in a week, then on the average 3.4 marks increases. So number of hours study. So if a student is studying 1 hour more, then his 3.4 marks are increasing. So even if the student does not study in a week, so suppose if it is zero, if he's not studying anything, then also he's getting 75.78 marks. But this may be due to because he's studying in the class, right? So even if the student is not studying at all, he is getting 75.78 marks, right? So this model fitting basically talks about the same thing that if a student is not studying, then he's at least getting 75.77 marks. But if he is studying for 1 more hour in a week, he gets 3.407 marks increases, right? So this is all about the commands that we have already done in our studio. So you can use all these commands again. This is a scattered plot. So first of all, you have to use a plot. So this the you have to use a function plot xy, and then your plot will be created. Then you will use apply, and then you will give this value, and then your fitted line will be formed, right? So coefficient is going to give you the coefficient, which is beta naught and beta 1, and model fitting using R. So then you will be finding the fitted value, and residuals will be finding the residuals, right? So all this thing is given to you over here. You can write all this command and you can do this, right? So next I wanted to show you something very important. That means I have already prepared an MCQ for you. So I would like to show those MCQs which are very important. And this is again based upon whatever we have studied in the class, right? So those MCQs are very important and you can basically identify that whatever you have studied and you can do those MCQs. So these are the MCQ which I've shared with you. So these MCQs are very important because they will actually help you to identify that you have understood everything that have been taught to you. So first is, what is the main objective of linear regression? So basically, we can start the quiz from here, and then you can basically, uh, you know, identify this is the code that will be given to you, and then you have to just fill this code. You have to use joinmyquiz.com and this code, and then you can start a quiz, right? But other than this, I'll be showing you the question so that you understand that what are the expected question in the quiz, but the answers will not be available, right? So we just have to do not show the answers. So first is, what is the main objective of linear regression? To classify variables, to predict dependent variable using independent variable, to sort data, to remove missing value. So this is the objective of linear regression, that we have to predict the dependent variable with respect to the independent variable. In linear regression, y is equal to b naught plus beta 1 b1x. So what is b naught? B naught is called as your intercept, right? So let us show the answers also. So in the regression equation, so you can say to predict the dependent variable, in the regression equation, y is equal to b naught plus b1x. So what does b1 represent? B1 represent the slope. Which R function is used to create a linear regression model? So R function is LM. LM, which is linear model, followed by the parentheses, are used to create a linear regression model. Which R function is used to create a scattered plot? It is a plot function. Which function is used to add the regression line to the plot? So this function AB line is used to add the regression model to the plot. Which function returns the regression coefficient in R? So we use the coefficient function in order to return the coefficient in R. Which function is used to obtain the fitted? So fitted dot value function is used to obtain the fitted values in R. Which function returns residual values in R? So residual function is used to represent the residuals value in R. We have already used these functions. What is the residual? Residual is a difference between the actual value and the predicted value. Which symbol is used to specify the regression formula? So it's a tiddle. Tiddle symbol, which basically used to, so when we write lm, then we write y tiddle x. So this is in lm y tiddle x, which variable is dependent? Y is dependent. Which variable is independent? X is independent. Which function is used to create a vector? For vector, we have C, right? The collect function. So that is y is equal to C, and then we write the values inside that. Which of the following represent the correct syntax to plot a regression line? So this is the correct syntax, which is the absolute line and lm y tiddle x. What does lm? lm basically stands for the linear model. What type of plot is used to create plot xy? So in order, whenever we write plot xy, we create a scattered plot. What does fitted dot value return? So fitted dot value basically represent the predicted values, right? The predicted values, which is on the line. Which of the following is used to visualize relationship between two variables? So we know that which plot is that? That is a scattered plot. Which function is used to calculate the residuals in the regression model object? So residual function. Again, this is a case. Now, like a company studies relationship between the advertisement spend and sale, regression output intercept is 50, x is equal to 4. So what is the regression equation? Very simple. It is y is equal to 50 plus uh, here this must be b1. This must be b1. This must be the slope. So 4x. So that's why x value is not given, but this is incorrect. This is b1. This is the slope. Slope is equal to 4. So therefore, the equation is here b naught is given, b1 is given. So y is equal to 50 plus 4x. A company studies relationship between the advertisement spend and sales. Regression output is uh, 50, intercept is this, and x is equal to 4. If advertising increases by 1 unit, sales will increase by 4 unit, right? So if it is increasing by 1 unit, the sales is going to increase by 4 unit. So a company studies, this is the same thing, regression output is 50 if advertising is 0. If even there is X is 0, like B1 is 0, then what is the value of Y? It is 50, right? So here the regression output is 20, intercept is 20, X is 5. If a student studies for 6 hours, so here it is B1, B1 is 5. If a student studies for 6 hours, what is the predicted score? That will be 20 plus 5 into 6. That is 30 plus 20, it is 50 is the answer. If slope is positive, it means if X is increases, Y is increases. So intercept is 30,000 and B1 is 2,000. So what does the slope represent? That the salary increase per year of experience. So this is the same question that we have. So our function for the regression model, this we've already done. Regression line, we've already done. And these are all the questions that you can do, right? You can easily do these questions, right? They are very simple to understand. And they are all based upon whatever we have done in this particular session. So that was all for the today's session. I hope you have really understood that what are the concept, right? So in this particular session, we actually did that. What is the linear regression? So we started with initially that what is the linear model? A model could be a linear or a non-linear. Here we basically studied the linear model. Then we did the simple way to calculate B naught and B1, which was the most important part of this lecture. So we did the method which is called as your ordinary least square estimation method, and which is also called as the direct regression method in order to find what is the value of B naught and B1. So the value of B naught that we calculated was Y bar minus B1 X bar, and the value of B1 that we calculated was SXY upon SXX. So the value of XXY is written as summation of xi minus x bar and yi minus y bar, and xxx is summation of xi minus x bar whole square. So this is our call as the residual, which is B naught and B1. Then we have used the different the different kinds of commands in R in order to find out that what is the coefficient, what are the residuals, and what is the fitted values. And we have also find out the LM and we LM which is y tilde x in order to find out the coefficient x B naught and B1. And this is all we have done in the today's session. And we also did a lot of mathematical equations over here. And in order to find B naught and beta 1, so that you understand that what it actually means, because in R, you simply have to write the command, but it's very important to know the mathematics behind the model that we actually are studying. So thank you very much.